So for question 5, we have we're given a point on the circle when the Ferris wheel broke down. So we're at this point. So notice that's going to be a third quadrant point because x is negative, y is negative. What is the measure of the angle in radians that has a vertex 0, 0 and rays through the point 0, 35, 0. Also, what's all this mean? Well, 0, 30 or 35, 0 is where Michael started, right? Here's this. So what we're doing is we're measuring the angle from here to over to here. Give a little bit more room. And we're saying that this point here has the coordinates negative 33.807 and negative 9.059. What is the measure of the angle in radians that has a vertex? So what is, how many degrees is this? Well, we could use either sine or cosine or sine, right? If we use the x coordinate, we're going to use cosine. If we use the y coordinate, we would use sine. Because on this, what are we given? We're given the point here. So we know that this value, this coordinate is equal to 35 times the cosine of theta. Okay, because if we knew what theta is, 35 times cosine, that would tell us where we are. And again, this in terms of feet from the center, not just in terms of the radii, right? So that's going to be that. So how do we do that? Divide both sides by 35. And then we can do an inverse cosine. So what we do is we take the inverse cosine of negative 33.807 divided by 35. And you could also do this with the sine, but we're gonna use a cosine. That's what theta is going to equal. So we are in degrees. So this is kind of a thing when we switch back and forth. This needs to be in radians, right? Has to be in radians. I guess it could be degrees. Do they tell us? Let's see. Yeah, because we want to calculate it in radians. So let's come back. This is again something you want to get used to when, especially in taking a test, is to make sure you're in the right mode. Radians. So we're going to take inverse cosine. Cosine to the minus 1, that's what we want. The inverse cosine of negative 33.807 divided by 35. So give us an angle measurement in radians. But we're going to have to be careful here because this is not actually our answer yet. So we get that this equals 2.8797. Inverse cosine is a function that is limited to 0 to pi. So the angle it gave us, it's basically giving us the angle in the second quadrant. So it's giving us this angle. We want this same sort of reference angle down here. So what we're going to do is take, so if we went that way, we would get that same angle. There's a couple ways we could do this, but maybe the easiest is if we think of it, if we went that same degrees, if we went backwards, it would work. So this would be a negative angle. So if we take 2 pi and we subtract this angle, we will get this angle here. Okay, so let's do that. 2 pi minus, oops, minus 2.87974868. Use them all, why not? You could also copy the answer there. And now we've got 3.4. Okay, which matches the answer in the solution guide, right? But more importantly, we hopefully can understand how we got there. You can't just use this as our answer because that's a second quadrant. Yes, it's less than 3.14, so it's not in the third quadrant. Our theta has to be 3.4034 because it comes from this calculation. Okay, so whenever using a inverse sine or cosine, we would have had to do a similar thing with inverse sine because inverse sine is not defined in the third quadrant, it's only defined in the first and the fourth. So we would have got a different angle, we would have had to figure out which way it was. Okay, but that's one example, working that way. How many feet did Michael travel along the arc before stopping? So we see this, it's, you know, so what we now know the theta, and we know it's referring back to the original, it's a 35 feet radius, right? So the distance, total difference, the arc length is our theta. 35 times 3.4034. We multiply these two out, and again, I've got the answer here, so I'm just going to go times, and notice it brings the answer down. I don't have to retype it. 35. So Michael has traveled, right, that's our S, 119.12 feet. Okay, so that's number 9. Number 5.